All right. Okay, so here we're in chapter 3, okay? And again, the stuff in chapter 3, like linear regression and correlation, I was going to skip over that. I'll come back to it if necessary, but I really want to get into chapter 4. So here we're in chapter 3. So really for now, this is review so far. Last time what we did was linear functions. And a linear function, it's really just a function. Well, one way to define it is it's a function whose graph is a straight line that's not vertical. Because if you have a line that's vertical, it's not a function to begin with. I'm not sure if you guys have heard of the vertical line test. I know I cover that in Math 104, but if you haven't heard of that, that's okay. Just basically, if a line is vertical, it can't be a function. And also, linear functions can be written this way, where m, is your slope, also called your rate of change, and your b, okay, is your f of 0. In other words, it's your initial value. That's what b is. Okay. In other words, it's the value of the function at 0. Okay. I did present the other way that y minus c equals the slope times x minus, but basically this is really all you need for this form. There's other ways to write an equation of a line, but this is really enough. Okay. And again, the rate of change, the idea with that is if you were to increase your input, your x, by 1 unit, your output will change by m units. That's what they mean by a rate of change. And again, it's also called the slope. You probably have calculated it before. We have done, an example or two of that. In fact, well, before we get to one, let's take a look at this. Again, these notes are posted on Blackboard. Well, the outline of them is posted. I'll post the full notes later. Okay. So again, with the slope or rate of change, to calculate it, it's really just this formula. You could think of it this way, where for some x1, you get the output. For some x2 not equal to x1, you get the output. Calculate this. But it's really the same as calculating the slope. That's all. You get any two different points on the line, right? And then you just apply this formula. Change in output over the corresponding change in input. That's all. And this is that picture, I think, if I remember correctly, I had it last time. The idea here was, again, as I just said before, if you increase your x, your input, by 1 unit, your output will change by m units. I mean, here it's going to increase. Of course, it doesn't have to increase. It could decrease. But that's the idea behind a rate of change. That's really the idea behind. Okay, so let's get to an example. So here's a linear function, right? F of x is 2 times x plus 3. Okay. So again, here, what I want you to do is to confirm the rate of change of the function is 2. I mean, if you think about the mx plus b stuff, you know it's going to be 2 because the slope rate of change is the coefficient of x. But what I'm asking you here is to do some calculations. Now, what's nice is you could take some explicit values for your x's. So what I do is I take x to be 0 as one of those x's. You could take any x you want, but I get x, and I calculate the f of that. So when x is 0, again, we get 3 here. And then we could take another x. Now here I'm doing x equal to 1, 1 unit more than 0. But again, since we're dealing with linear functions, you can really just calculate the slope. I mean, I happen to be doing that for 0 for these 2 points. But really, you could choose any 2 points you want. I mean, what's nice is about choosing, some 0 and then 1. Let me say it this way, about choosing something and then choosing a number that's 1 unit bigger, you can see that the y value is going to increase by 2 here. But to really bring it home, we should calculate the slope, and that's what I'm doing here. So, the slope turns out to be 2, which is what we should expect. But again, also notice, if you increase x from 0 to 1, your y is increasing from 3 to 5. It's increasing by 2. Not only that, we can graph this thing. I actually graphed it using what's called GeoGebra. It's a free software. I think they have it on the computers on campus. If you're on campus, if you're not, you can still download it for free. You don't have to, though. I also graphed this little triangle to try and help illustrate that rate of change. Right down here, you can see that x is starting at 0. Below 0, you really can't see. And you're increasing it to 1. And you can see that the y value starts at 3, and it's going up 2 units. That's all. It's just something I felt better illustrating, so I thought it'd be good to do. So that's one example. Okay, again, just not too bad. And really part of the second example here, there we go, is this will come up when we do some word problems. When you have the slope, right, the units for it are going to be the units for your output divided by your units for your input. Same thing with rate of change. You might see in a word problem something like, someone is spending $10 per day or $100 a week. When you see something like that, you should think, oh, rate of change. You'll see what I mean when we do some word problems today. But that will come up, though. It's just something I felt better pointing out, this unit stuff. Units for output, units for input. So again, you'll see that today when we do some, not many, but some word problems. But here's another example. So here we have, this came from the textbook. I don't remember what number it is, but it is in there. But basically what I have is we're going to let v of x, that's going to be our value in thousands of dollars of some investment we're making. Now, what is that investment? I don't know, but for the purpose of this example, who cares? So it's the value of that investment after X years. Since we know v of x, as you can see, it's a linear function, right? You have mx plus b, m is some number, b is another number. So notice also you have x alone. You don't have like x squared, x cubed, or something like that. Okay. So the first thing they want you to do is calculate v of 10. Well, how would you do that? You just replace x by 10, right? And then you do the calculation, as you can see. Again, if I go too fast, just use the hand feature or say something in your microphone. I won't get upset. I want to make sure we're learning this. Okay, so v of 10 by direct calculation is this. You just replace x by 10, right? That's all you do. Okay. And you can see that we get negative 19.8. But remember, the units for this, as stated here, is in thousands of dollars. So it's negative 19.8 thousands of dollars, which is equivalent to this. Although there should be a negative there. Let me just quickly fix that. I thought I fixed that in the notes. So it's negative $19,800. Okay. So that's what happens here. Okay, but what does this mean? Because we also are being asked to interpret the meaning. So what does this really mean, though? Well, after 10 years, the value of the investment has decreased, right? That's what the negative is. It's decreased by $19,800. So 10 years later, after I guess we made the investment, the value of it has decreased by $19,800. Okay? So we get that. Okay, now, what is the rate of change here, right? Well, that's always the coefficient of x, right? So in this case, the rate of change is that negative 5.4. And remember also the units above it. So the units for the rate of change here will be thousands of dollars over years. Thousands of dollars, right? That's our output unit. Our x is years. So that's what the units are going to be. So I just said that already. So for the rate of change, right, that negative 5.4, thousands of dollars per year, that is telling us the investment is decreasing in value. It's decreasing by 5.4 thousands of dollars per year. So each year it's going down by 5.4 thousands of dollars, or $5,400. Same thing. Okay. All right. Before we get to the next one, just gotta stop the recording.
I have a question.
Okay.
Since it's in 10 years,